In this particular question, we've been given the cubic function y equals 2x cubed minus 3x squared minus 12x plus 1. And we've been asked to find its minima and maxima as well as its increasing and decreasing intervals. So we start by taking our first derivative, y prime, which is equal to 6x squared minus 6x minus 12. And we set that derivative equal to 0. What you'll notice is that we can divide everything on both sides of the equation by 6 so that we end up with 0 equals x squared minus x minus 2. This quadratic equation can then be factored by inspection, and we can solve for x, and x is equal to 2 and x is equal to negative 1. So these are the x coordinates of my critical points. I now need the corresponding y coordinates. So I substitute these x values back into my original cubic function, and when x is equal to 2, my corresponding y value is negative 19. When x is equal to negative 1, my corresponding y value is 8. So now I know that I have two critical points, their coordinates being 2, negative 19, and negative 1, 8. We don't know which one of those critical points is a maximum and which one is a minimum. We actually do, because we have an extensive knowledge of cubic functions. But instead of using that knowledge, what we're going to rely on is our second derivative. So we take our second derivative, y double prime, which is equal to 12x subtract 6, and we substitute in our first x value, 2, into that second derivative. And we find that y double prime is equal to 18 when x is equal to 2. Our second derivative in this case is greater than 0. So we know that the function is concave upwards at this particular critical point, meaning that the critical point 2, negative 19, has to be a minimum. We take our second derivative again, y double prime, which is equal to 12x subtract 6, and now we substitute in our other x value, negative 1. And we find that y double prime is equal to negative 18 when x is equal to negative 1. This means that at this critical point, our function must be concave downwards because our second derivative is negative. If it is concave downwards at this critical point, it means that the point negative 1, 8 must be a maximum. Now we still have to figure out where the function is increasing and decreasing. So what we need to do is say, where is our first derivative positive? It's positive when our function is increasing. And where is our first derivative negative? Well, it's negative when our function is decreasing. So we start by taking our derivative, y prime. We've already set it equal to 0 and solved for x, and we found x is equal to 2 or negative 1. These are the values of x that set the first derivative equal to 0. Now we want to find the values of x which make that expression positive, and then in the other case negative. So we set up our number line, putting our two x values down on that number line, negative 1 and 2, and now we're going to test our first derivative in those three regions. So I'm going to test y prime, which is equal to 6x squared minus 6x minus 12 when x is equal to negative 2, x is equal to 0, and x is equal to 3. These are the values I've chosen in my three intervals on my number line. You could have chosen other values that would have been perfectly acceptable. When x is equal to negative 2, y prime is equal to 24. So I place a positive value on my number line to indicate that all first derivatives in that region from negative infinity to negative 1 would produce positive values for our first derivative. When x is equal to 0, y prime is equal to negative 12. So I now know that any x value that I choose between negative 1 and 2 would make my first derivative a negative value. And then I choose the x value of 3, substitute that into my expression for my first derivative, and I find my first derivative is equal to 24, a positive value, and I place that on the number line. Increasing intervals occur when our first derivative is positive. So I can conclude that my function is increasing when my x values go from negative infinity to negative 1 in union with values between 2 and infinity. A function is decreasing when its first derivative is a negative. Therefore, we can conclude that the function is decreasing when my x values are between negative 1 and 2.